collection of texts that are reviews of one particular product. If you had a general collection of text, something like this would probably not work very well. So, the primary step that you do is straightforward association rule mining. So, something like anything with greater than 1% support is a candidate frequent feature. And then you use some kind of a refinement. So, you keep features that have compact occurrences. What do I mean by compact occurrences? The words in the group must occur close by. So it's not enough for kind of words to be spread all over the review. Additionally, look at something like manual mode and manual setting. Is manual a separate feature by itself or is it not? It could be. I mean, it's plausible if you're talking about the quality of the user's instruction manual given with a product. So, is that a feature or is that used as an adjective where you have manual mode, manual setting? So after all, your part of speech tagging is also something that's automatic. So you might have made a mistake here, and I mean, after all, manual mode is a noun group. You may or may not have identified manual separately correctly as an adjective here, as an adjective here, and as a noun over here. So if you're just working with words, what you do is you could think of, does manual occur most of the time followed by words like this, or does it occur in isolation also a sufficient number of times? If it does, then you can pick out manual as an individual feature. If the individual occurrences are too few, then you disregard it. And you keep things that are bigger or which subsume this, like manual mode and manual setting. So essentially, I mean, the idea that you've used here is crucially dependent on this part of speech tagger. So the part of speech and tagger identifies the nouns and the noun groups, and after that you do some fairly elementary refinements. The sentiments are, remember I said they were mostly adjectival in nature. So just like we were looking for nouns in the earlier step, we will be looking for adjectives in this step. So here again, I mean, the actual method adopted is fairly naive, and you can easily construct counter examples where this method will not work. So the idea is something like, if you've done a reasonably good job of identifying the features, the next thing that you do is, given a particular review, you identify the candidate features in that document, and for each feature in the neighborhood, you look for adjectives. And to start with, you simply hypothesize that given something that's been identified as a feature, if you have an adjective closest to it, or I mean whatever adjective you have closest to that feature, you identify as being the opinion about that feature. Provided, of course, that it's within a certain distance. I mean, if you have one feature here and the closest adjective happens to be somewhere else, you don't want to regard that. But if it's nearby, then whichever is closest, you regard that as the potential opinion about that feature. Okay, so now the last thing we need to do is determine whether a particular adjective is favorable or unfavorable. So again, preliminary algorithm, baseline algorithm that you could start with, make a list of some commonly used adjectives. Like the examples that we saw earlier, fantastic is probably a favorable thing to say. Good is good, bad is bad. So you make a starting list like this. And what you do then is kind of, if you encounter an adjective that you do not know about already, you can use a resource that I talked about earlier, that's called WordNet, which is basically something like an electronic thesaurus. So what WordNet does is, it has a noun section, a verb section, and an adjective and adverb section. And the words are kind of grouped into what are called synsets. So a synset is short for a synonym set. So one set is a set of words which have the same meaning or same sense. So think of WordNet as a graph where each node in the graph is a synset, and the edges tell you the relationship between different senses. So relationships like hypernymy and hyponymy, where a hypernymy is a generalization and a hyponymy is a specialization. So something like a cat would be I don't know, cat and related terms would be kind of a hyponym of animal. So the animal is a more general concept, a cat is a more specific concept. So that's the kind of linkage that you would have among nouns. But in this case, we are more interested in the types of links among adjectives. So one of the links that are provided by WordNet are, or one of the link types is antonymy and synonymy. So you can see that the adjectives are already arranged in bipolar structures. So you have one group of adjectives here and another group of adjectives here. If they are related, then you have either a synonymy or an antonymy link between them. So starting with a kind of seed list of adjectives for which the orientation is known, what you try to do is, suppose you know that good is good. You find good in the WordNet graph and you try to reach from a known node to an adjective that you've encountered for the first time in a review. In doing so, you cross maybe some synonymy links, some antonymy links. So if you cross an odd number of antonymy links, the word that you reach is probably opposite in orientation. If you follow just synonymy links, or it's a special case of an even number of antonymy links, you assume that the new word that you've encountered has the same orientation. So, I mean, you can tell, I mean, there's no rocket science in these ideas, but it gives you a system that's a starting point, and you can try it out on data and see how it works, where it fails, and that's a starting point, because then you kind of get to find out, or you can obtain ways to define these methods further. So, I mean, the ideas themselves are straightforward, and the crucial thing that you have to depend on here is the accuracy of the part of speech tagger and the chunker. So what I'll end with is a list of some data sets, and there are many more, that you can use as kind of raw material. And some of these, all of these are labeled data sets, which is to say that they have ground truth associated with them. So if you want to kind of do something like kind of study opinion mining a little further, some data sets have already been gathered for you, so you could use them in your own research. So these are standard data sets. Makes it easy to compare your method against methods that have already been reported in the literature to see how well your algorithm does compared to what exists. Okay, how much time do we have? Okay, so then I'll stop here. Here are some additional references, particularly the last two. For basics on information retrieval, this is a very good textbook, and the almost final version of this text is available on the web. Web data mining, this is another textbook that deals with not only the kind of stuff that I've talked about, but other things related to web data mining, like structure mining, which I just mentioned, but we didn't talk about at all. Web usage mining, so that kind of thing is covered here. For something more specific, this contains information on opinion mining as well. For a slightly more updated and more comprehensive picture, you can look at this paper, Opinion Mining and Sentiment Analysis. And I think there's a more recent version of this as well, but I have not put it up here. So maybe I'll like the web version. I mean, when these slides go on the web, I'll try and find that additional reference and add it over here. Okay, so that's all I have to say. Yes.
So in the feature identification part.
Sorry, where are you located? Can you raise your hand? Okay, sorry.
In the feature identification part,
yes.
I couldn't get what did you mean by transaction creation for each sentence?
So each noun, basically, like you identified the noun groups. So any noun group that occurs together is a transaction. So, I mean, it comes from, I mean, are you familiar with traditional data mining algorithms like association mining for market basket data? Okay, so then basically the idea in traditional data mining is that, or I mean, where association mining came from, is that one transaction, you sort of think of a table where the columns are items to be found in the market, and each row corresponds to a set of items purchased simultaneously. So you want to find relationships like, if you look at, I mean, if you collect information over a large number of purchases, are bread and butter bought very frequently together? So that's the kind of the starting point of association rule mining. That's the example that's been used there. So what we do over here is each sentence becomes a transaction, and the noun groups that you identified there, they are, as it were, the market basket items. So you are essentially looking at, in fact, I mean, it is just to put this in the traditional data mining framework, but other than that, I mean, really the transaction part of it does not have very much significance. What you're really looking for is which of the items have occurred sufficiently frequently. In this case, I mean, co-occurrence of features is probably not what we are interested in. I mean, given that something is frequent, we want to look at adjectives that occur nearby rather than other features that occur nearby.
Excuse me.
Yes.
So, what did you mean by manual thesaurus? That part I didn't get you.
Oh, so Rogers thesaurus, that's the kind of, you usually find it as a hardbound book, but nowadays it's also available online. Lexicographers have actually sat down and put together thesaurus by hand. So, based on their knowledge of the language, they say things like warm is kind of similar in meaning to hot. That kind of, but it's done by experts, not done automatically.
And how are automatic thesaurus constructed?
So the kind of the association mining technique that I talked about.
Okay, those are for automatic.
Yeah, it's usable to varying degrees. Like anything that's completely automatic, it's not foolproof. But I mean, because it's based on certain hypotheses, it is subject to verification. So the particular experiment that I talked about, in practice, turned out to work well. That is not to claim that it's a foolproof methodology.
Thank you so much.
Hello. Professor Mitra.
Sorry, where are you?
Just I had a couple of questions. The general questions only. When we are matching two words, so we might encounter spelling mistakes and SMS language also, like Percode, JWOT and GUD also. So, is there any standard approach for handling those scenarios?
Okay, so part of it would depend on what context you're in. If you're in an SMS-like setting, offhand I'm tempted to say that the safest thing to do would be to build a list.
Okay.
But if you're dealing with, I mean, you think of something like what Google does with did you mean? There the advantage is that they have logs of billions of queries.
Right.
So given a particular word, they know what are the nearby words in terms of any distance. They have noticed that a mismatch is, I mean, the position of the mismatch
Right.
is not terribly significant. You could misspell or mistype the first letter as well as the last letter.
Yeah.
So you're looking for words that are nearby in terms of any distance, and if you find that a nearby word has occurred very significantly, you might want to suggest that as an alternative spelling.
Through my experience, I found like dropping vowels and just going by the consonants. Is that a sophisticated approach?
Whatever works is good. I don't want to get into questions of whether something is sophisticated or not. Like I said, I mean, counting word pairs is not terribly sophisticated,
Okay.
but works well. So whatever works, you use it.
One more question.
Yes, sure.
Under this opinion mining, so what if we encounter pictures,
Ah.
like smileys. Are there any softwares to handle them?
I don't know of any tools, but like I said, I mean, this was an absolutely bare-bones starting point. So, you can, like sitting here, you can think of refinements that you can do to these things. So, smileys would be one of them.
Right.
So, presumably, I mean, a smiley would be a positive opinion. If you are frowning, then that's probably a negative opinion.
Especially in blogs, they just upload some pictures. Not only smileys, some pictures they upload. So, is there any software to basically analyze them?
I don't know of any, but that's, I mean, I don't want to say that that's kind of gospel truth. It's just my ignorance rather than anything else. So don't kind of lay too much stress on that answer.
Thank you.
Hello. Entire presentation of yours is in line with the bag of keywords technique in literature.
Absolutely.
The application of either the cosine similarity or Jacob constant similarity for achieving document similarity or duplicate document finding, how much it is advisable to put any statistical measure to conclude that this document relevance can be made of using these two approaches.
So I'm sorry, what was the second approach that you mentioned?
Jacob
coefficient
and cosine similarity measures.
Right. So in traditional searching, it's almost always some variant of cosine similarity. Cosine similarity itself comes from the vector space model of IR, but even if you're using some other model, you'd be using something similar. So kind of something that looks at matches between a query and a document and adds up the weights of the matching keywords. If you're in a retrieval-like setting, that's probably the best thing to do. Depending on what the problem is, something like dice coefficient or Jacob coefficient might be more useful. Remember I talked a little bit about query expansion. So some work done on applying WordNet to query expansion does in fact make use of dice coefficient or Jacob coefficient fairly effectively. So I think that's, I guess I don't want to predict what will work and what will not work, because you can see that some of the results that we've experimentally found can be counterintuitive. Like language knowledge turns out not to work significantly better than statistical techniques. So in a sense that's counterintuitive. So rather than kind of predict in advance that such and such a technique is going to work or is not going to work, it's best to look at past experimental results. What is your problem and whether something like this has already been tried or not. If it's something new, try it out. I don't know in advance whether it will work or not. I mean, if it's related to some earlier technique that works well or does not work well, then one might hazard a guess, but no more than that. I mean, all of this is very empirical, so anything is subject to experimental verification.
In the area of pre-processing, you have told that Porter stemming algorithm is for stemming purpose. Is it advisable to use lemur stop word collection, which claims that it will have all the stop words, especially in the English language, to remove?
Lemur, that's from Lemur Indri, that toolkit, is that what you're talking about?
Yes.
That's a standard toolkit. You can safely, reliably use it.
Is it still on date? Is it advisable to use it, Lemur, or any other tool which is equivalent to Lemur for?
Well, I mean, they're mostly kind of, I mean, things like Carrier, Lemur, these are probably more or less equivalent, depending on what model you want to kind of base your work on. If you're doing language modeling, then Lemur and Indri are probably the best bets. If you want to start with divergence from randomness, then you're probably better off using Carrier. If you're very brave, but you want a lot of flexibility, then there's probably nothing to beat Smart, which is ancient, but much more flexible than either Lemur or Carrier. But because it's ancient, it doesn't have any of the new retrieval models in it. But it's amazingly flexible. So you pick one and you kind of stick with it.
Thank you, sir.
I think limit is fine as one choice.
Sir, sir,
Yes.
what is an aggregation, sir? I can't understand sentiment analysis you are saying.
So it's something like you have some 100 reviews about a product. So aggregation is essentially presenting a summary, like an overall rating or an overall summary, something like that.
Sir, text classification stemming stopword is there. Suppose quotations and punctuation marks like that. How can I remove that?
I mean, straightforward tokenization. I mean, you look at, you have something like is punct. So if it's punctuation mark, you throw it away. I mean, the only slightly tricky questions there are a hyphen. I mean, do you regard a hyphen as separating two words, or do you want a hyphen separated word as one word? I don't think there's any conclusive, foolproof answer there. You pick one and stick with it. It's going to work some of the cases. It's not going to work in some of the cases. It's not going to make a whole lot of difference.
So just a small question from my side. In the opinion mining section, you were talking about the sentiment identification. So there primarily you talked about the adjectives, and then we were talking about how to go about with that. So of course it's very easy to see that even nouns and verbs can play a role in, emphasizing an opinion. For example, somebody may say it was a big pain, or whatever.
Absolutely.
So actually I was just trying to cross-check from you if I'm thinking in the right direction. There is something called as these affine parameters, which kind of gives some weightage from -5 to +5 based on the effective words. So effective words with the A are those words which kind of reflect your sentiment or reflect your mood. They are kind of mood related words. So have you seen some work in that area regarding affine parameters?
I mean, the term affine parameters is not familiar to me, but there's something called sentinet.
Okay.
Like, so I talked about WordNet, which is basically an electronic thesaurus. There's something called Sentinet, which I've never used, so I'm not familiar with it other than the name. But Sentinet is something like a knowledge base that's useful for this kind of opinion mining sentiment analysis. So that is relatively recent. This work that I talked about is among the first attempts that were made at opinion mining. So all of this predates Sentinet. But if you look for Sentinet, you'll find it.
Yeah. I think I have also heard of Sentinet. It I think uses affine parameters.
Possibly. I don't know how it works on the inside.
Sir, I have a question. That is, how far topic modeling is related to feature identification?
Sorry?
Topic modeling is related to feature identification.
To feature identification.
Yes.
Well, I mean, people use topic modeling as some kind of a retrieval model, but I'm not sure I can give you a crisp answer to that question. I mean, how do you mean, how is it related? I mean, people use it like people use bag of words, people also do topic modeling for kind of retrieval purposes. But I guess I don't have a specific answer to your question. Can you make your question a little bit more specific?
Actually, topic modeling is somewhat blog analysis. While doing blog analysis, and what topic they are going to address, and based on that we can go for whether it is a polarity wise, you can guess the polarity on that. Under that we have topic modeling. Even as per our lecture, I saw the feature identification, particularly in e-commerce sites. Feature identification is a particular feature, particularly in a camera like or electronic goods. Feature based on a particular feature, we are going to rate on that. Similar to that, we have topic modeling. Is there any relation between these two?
As far as I know, but this is not something I'm terribly sure about. Topic modeling is probably not going to tell you about sentiment. As far as I understand it, topic modeling mostly has to do with kind of estimating how kind of one topic represented by a set of keywords is related to a particular given piece of text. As far as I know, it does not give you what the orientation of that, whether it's positive or negative. That part I think you would need manual labeling. If you label certain things as positive, and then you might kind of see how well that is predicted by a given piece of text and infer its orientation from that. But without that manual step, I don't see how you kind of be able to apply topic modeling to sentiment analysis. Here here also, I mean, we started with a set of adjectives that were manually marked as favorable or unfavorable. Even if you're using topic modeling, I think that's what you need. But other than that, I think it should be useful. But I know very little about topic modeling, so it's not at all a reliable answer.
Probably last two questions, one here, one here.
Sir, in case of sentiment identification, how to deal with the sarcastic comments?
I don't know. I mean, that's a challenge.
Yes, sir. Because I am trying some machine learning algorithm to draw the curve of the polarity of the comments. And based on that, if some deviation was there from the gender trends, so on that basis, I was trying to figure out that comment can be sarcastic.
So, I mean, how did that match with ground truth?
No, sir, that's challenging.
I don't have an answer.
Sir, how to deal with the ambiguous adjectives? Like some adjectives are both for positive sense also and some negative sense also. And how to deal with those adjectives?
Okay, I can kind of give you an answer that's really meant for a different question. So it's sort of like what you do for word sense disambiguation, which is where like you have one word that can mean multiple things, and you look at its surrounding words to determine which sense it has been used in. So here too, as a first guess, that you might want to do something like that. Given an ambiguous adjective, look at what words it's been surrounded by, and then you need some labeled data which will tell you whether that kind of a context connotes a positive sense or a negative sense. But I'm just guessing, I don't know.
Thank you, sir.
Hello, sir. So it seems like designing or doing text mining for example that you gave. So is it advisable to use like translate APIs in the back in the back of the scenes and maybe just convert it to English and then just the keywords would be obtained at least.
Sorry, say that again.
For example, like you took up, for example, different languages.
Something like mining or text understanding, now you are compounding those with the translator's errors. So if, I mean, most things that are statistical, you should be able to apply across languages without a lot of effort. That would probably be the safer way to go. I mean, if you have an effective translator, that probably already means that you have effective language processing tools. In which case you might be better off using the language processing tools directly as building blocks rather than using the output of the translation. I mean, translation is a complicated process. In only cases where you don't have any language resources at all, you'd use a translate API. But some work being done on kind of, this is kind of what I don't think this has been published yet, but the idea behind the work is, I mean, will probably give you a partial answer to your question. So the idea is something like, we have, like, suppose most of us are multilingual. So I can read documents in both English and Bangla. So I don't want to type two separate queries. I type one query and I want to get back both, I mean, documents in both English and Bangla. So that's called cross-language search. So the best case would be for somebody, for some human, possibly myself, to translate my query properly into, I mean, suppose I have English, I represent it in English in one way, and if I were to start from scratch, how would I write it in Bangla? That's the best case that's achievable. What we could do is have the query run through the translation API, run the output and see how well that does compared to a manual translation. So naturally it's not going to be as good, but depending on what translation engine you're using, you'll get varying levels of performance. So I know of one study that's compared the Google Translation API with some of the publicly available translation APIs that have come out of kind of projects funded by the government. And well, I mean, the final result is that the Google Translate API works a lot better. But I don't have figures for how well the Google Translate API works compared to manual translation. That it's worse, but I don't know how worse. So, I mean, you should probably, I mean, if you keep an eye out. You'll probably see that work reported in the literature next 3 or 4 months or so.
So at least we won't get nice phrases. For example, in Hindi, in Hindi I type "मैं यहाँ हूँ," so what it would the Google Translate would "I here am." Though we are not getting the syntax correct, but we are at least getting like the keywords.
Some of them, yeah. So I mean, depending on what you're trying to do, you don't, like I said, I mean, you do that only if you have nothing better. I mean, if you don't have a better alternative. If you're doing regular retrieval, that does not involve too much language analysis, you're fine at the string level and you do things like statistical phrase identification, statistical stemming, you'll be fine. You'll probably be better off than using